Hi and welcome back to Show's classes. Today we are going to be dealing with homogeneity checking and returns to scale. Let's begin with a very simple question. For homogeneity checking, the very simple procedure is whenever we are given a function f(x,y), put the value f lambda x lambda y. Then whatever we'll get as the power in this form, whatever the power that will be, let's assume it as z, that is the homogeneity power or degree of that function. Let's see with the first question. For example, in the first question we have fx comma y equals to root xy. Now how to find it? Put the value lambda x lambda y in this function. This comes to root square xy, which is equals to lambda root over xy, and root xy is nothing but lambda f x comma y. The power over here is 1, thus this function is homogeneous of degree 1. Let's try out another a little bit difficult question. Now we have a function that's a little bit different. We have x cube minus xy plus y cube. In order to check homogeneity, we'll again put lambda x comma lambda y in this function. Let's see what this comes to. In this we have lambda cube x cube minus lambda square xy plus lambda cube y cube. Notice we cannot put this function in any form such that a lambda can come in a form such that f x comma y into lambda can have a power over here. Thus this function is not homogeneous. It is very important to notice this step, because many times this kind of question is given to check whether we know how to do our sums. Now we have an equation where there are three variables, notably x, y and w. The equation might look scary, but it is actually very easy. In this case we'll substitute f lambda x comma lambda y comma lambda w, which equals to lambda cube x y square by lambda w plus 2 lambda square x w. This comes to lambda square x y square w plus 2x w. This is nothing but lambda square f x comma y comma w. Hence we have put this in this form. Thus notice the power, it's 2. Thus in this case the homogeneous degree is 2 of this function. Now we are going to do a very different but a very important question. We are given with a production function q equals to a k to power alpha l to power beta. The first question is given as a alpha plus beta greater than 1 implies increasing returns to scale. We need to show and prove that. Let's see how to do this. Since the function is given that it's homogeneous of degree alpha plus beta, if alpha plus beta is greater than 1, the value of the function increase more than the increase in k and l. That means when k and l is increased j fold, for example, the value of the function increases much greater than the increase in this values of k and l. This implies increasing returns to scale. Similarly, we'll see for the next one. The second question says that when alpha plus beta is less than 1, it means DRS. Now if that is the case, that alpha plus beta is less than 1, we can see that when k and l is increased j-fold, the increase in the value of this function, that is q increase, is much greater than j-fold, which implies a decreasing returns to scale. I'm sorry, I just said increases. Rather, the increase is less than the increase in k and l. Now the third question is a bit mathematical. Alpha and beta are respectively the partial elasticities of output with respect to the capital and labor inputs. We need to show this. How? Let's take log of this function, that is ln q equals to ln a plus alpha ln k plus beta ln l. Thus elasticity qk equals to delta ln q by delta ln k, which equals to alpha. Similarly, elasticity ql equals to delta ln q by delta ln l, which again equals to beta. Thus this is the answer that we need to show, and we need to see that these are the respective partial elasticities of output. The word partial is very important in this case. Now let's quickly do a complex sum. It might be complex, but it's very easy to do. Let's see what it's given. Q equals to a k to power alpha l to power beta n to power c. In this function, we need to check homogeneity and its degree. Let's see how to do that. Let's repeat our process. Let's assume q equals to fkl. Since in this case there are three variables, we'll assume q equals to f, k, l, n. And now we will replace these values with lambda k, lambda l and lambda n to figure out the homogeneity. Let's see what it comes. This comes to a into lambda k to the power a, lambda l to the power b and lambda n to the power c, which is equals to lambda a plus b plus c into the original question, that is q. Thus the degree of this function that we are given is a plus b plus c. Thus q is homogeneous of degree a plus b plus c. Moving on to the next question. Now we need to check the conditions under which this equation will be a CRS and an IRS. For constant returns to scale, lambda a alpha plus beta plus c equals to lambda, that is alpha plus beta plus c equals to 1, and this implies constant returns to scale, or CRS as we usually call it. Sorry, this will be a, please note it. Now for increasing returns to scale, the value of a plus b plus c should be always greater than 1. Thus these are the two conditions that is required for IRS and CRS. Now let's find the share of the product for input n if it is paid by the amount of its marginal product. Let's see what that comes. Now the share of n can be found out by n equals to n into dq by del n by q, which equals to n a k to power alpha a l to power b c n to power c minus 1 whole divided by a k to power a l to power small b and n to power small c, and this comes to c. Thank you. In the next video we'll be dealing with Cobb-Douglas function and the series function. Press like, subscribe and stick with us for more such amazing videos.